Students, in the previous chapter we have studied about energy, and in that we have understood different types of energies: mechanical, potential, and then other energies like light energy, heat energy, sound energy. So in this way we are going to continue with light energy, which is your chapter number 5 and last chapter of your half yearly syllabus. So in this chapter we are going to learn about the definition of refraction. We are going to study about refraction, examples of refraction. Then we will study about prism, about the different types of mirrors, from where it has come, convex, concave mirror, and the rules of making the ray diagram, about the real and virtual images and the ray diagrams. So let us start. First of all, we are going to study about the speed of light in different media. The speed of light in air is 3 into 10 to the power 8 meter per second, and in water is 2.25 into 10 to the power 8, and in glasses it is 2.2 into 10 to the power 8 meter per second. Now here you can see in air it is 3, again in water it is 2.25, and in glass it is 2. So as we are moving from rarer to denser medium, air is rarer medium, it is transparent in nature. Then again glass, it is denser than air, sorry, the water, which is also transparent, but it is denser than air. And then we have glass, which is denser than water and it is denser than air. So as the material is becoming denser, the speed of light is becoming less, and the speed of light in air is the greatest one. You can see it is 10 to the power 3 into 10 to the power 8 meter per second, which is the unit of speed. Then it is said that medium is said to be denser if the speed of light is decreased, and medium is said to be rarer if the speed of light is increased. As you can see that in air the speed of light is more, and in water and glass the speed of light is becoming less and lesser. Then we have refraction of light. Now we will understand about refraction. So what is the meaning of refraction? The change in the direction of path of light when passes from one optical transparent medium to the another. Optical transparent medium is it can be glass, it can be water. That is why we have used optical transparent medium through which the light can pass easily. That is why we have used the term optical. So the change in the direction of path of light when it passes from one optically transparent medium to the another optically transparent medium, it is called refraction of light. Now there are some rules how light passes in from air rarer to denser, that is from air to water or from air to glass, and from denser to rarer. So our first case is from air to water or air to glass. When a ray of light travels from rarer to denser medium, say from air to water or air to glass, it bends towards the normal. Now what is normal, what is refracted ray, what is incident ray? We will just understand this. Normal is a straight line which divides rarer and denser medium. Incident ray is the ray which makes an angle with normal. This is called incident ray, which is passed from air. It is a ray of sunlight. Then we have the ray which is absorbed and bent downwards, this is called refracted ray. This is the angle between normal and the refracted ray. This ray angle is called angle of refraction, and this ray is called refracted ray. So when the light passes from rarer medium to denser medium, it bends towards the normal. This line is close to the normal, that is why we are saying it bends towards the normal. Okay, the next one is when the ray of light travels from denser to rarer medium, from water to air, from glass to water, glass to air, then what happens when light passes from water to air? This is the incident ray or the sunlight. So when the sunlight passes from water to air, this incident ray, it bends towards this bends away from the normal. This refracted ray which has been absorbed by the medium bends away from the normal. This line, dotted line, is the line of normal. So your refracted ray will be bent away from the normal. So this is the two ways how the light shows its nature when it passes from rarer to denser or denser to rarer medium. The next case is when the ray of light falls normally on the surface separating the two medium, it passes undeviated. Let us see the picture of this just given in the book. You can see when the light is incident normally, that is the normal is your incident ray, then what happens? No deviation or no angle is being made by the incident ray. So it will be 90 degrees. Now there are some terms which are related to refraction of light. The terms are incident ray, refracted ray, normal, angle of incidence and angle of refraction. Incident ray is, we have already studied that the ray of light falling on the surface separating the two media is called incident ray, and the ray of light traveling to the another medium, that is called refracted ray, and normal is perpendicular line or the dotted line which you have just seen. This is called the normal, and angle of incidence is the angle which incident ray makes with normal, and angle of refraction is angle which refracted ray makes with normal. So here you can see in the picture it is given, it is incident ray, this is your normal, this medium is taken as rarer medium, and the light which is deviated, this is called refracted ray, and the angle which is formed is called angle of refraction. Then we have Snell's law of refraction. So Snell's law of refraction is saying the incident ray, the normal ray and the refracted ray, they all lie in the same plane, and sin I upon sin r is equals to constant. It is given here. The ratio of sine of angle of incidence and the ratio of sine of angle of refraction is r. Refraction, that is r, is constant, that is it is taken as mu. Student, this new word you can see sine, which you will further study in your trigonometry in mathematics part in class 10th. So you have to only understand about sine. It is written like this, which is equal to constant, and this constant is called as mu, which is written as this way, which is given in your book. So speed of light in the first medium is equal to upon speed of light in the second medium. Now there are some effects of refraction of light. The effect is, there are two activities which can show the effect of refraction. The first one is when the coin is placed in the tub or a transparent glass, and when the stick or a pencil is thrown in the tub full of water. When the coin is placed in the transparent tub, you can see that the depth of the tub, the real depth of the coin, and the apparent, there are two depths of the coin, the apparent depth and the real depth. We can see two depths of the coin. The first one is the real depth and the second one is the apparent depth, which we see when we look at the coin obliquely. So we can understand this from this ray diagram, and this happens due to this phenomena take place because of refraction of light. So here you can see this picture. In this, when you look at the coin from the top, that is when you look at the coin normally without making an angle with your eye, you will see the correct position of coin. But when you will see it obliquely, what will happen? Refraction, you can see the phenomena of refraction in the coin. So what will happen? Incident ray, when it strikes the surface of water, it will bend towards the normal and you can see the coin raised up. In the same way, you can see the stick or a pencil which is placed in the water raised up. You can just do this activity at your home by placing a coin in a tub. So this take place because of refraction of light, which we have already studied, that incident ray which becomes refracted ray will bend towards the normal in this phenomena. So this take place because of the refraction of light. Now another example is the example of sunrise and sunset, and another one is the mirage which is seen in the desert. Now we will take this case of mirage which is seen in desert. What is mirage? Mirage is an inverted image of tree is seen which gives a false impression of water under the tree. This is called mirage, and this take place because of refraction of light. The cause of mirage is the refraction of light. In desert, the sand becomes very hot during daytime and it rapidly heats the layer of air in contact with it. Therefore, the layers of air near the ground are warmer and hence rarer than the upper layers, and so because there are two mediums are formed, that is rarer medium which is hot air and denser medium which is your cold air, and that is why refraction take place, by which we can see an inverted image of tree which gives false impression of water, as it will look like as there is a water. So that is why an image of tree is seen, but that is only a false illusion. Now another thing you can see is refraction of light through rectangular glass block. The rectangular glass block, you can see this is the rarer part, that is air, and this is your denser part. So when the incident ray will fall here, it will bend towards the normal, and then this refracted ray will act as incident ray, and again from denser medium to rarer medium the phenomena will take place, and this Afterwards, what will happen when we move from denser to rarer? It will bend away from the normal, and the ray which finally comes out of the slab, this ray is termed as emergent ray. So this is the new thing which you're going to learn. This is called emergent ray. Now this emergent ray can be seen in case of prism. Now we will study about prism. Prism is a rectangular medium bounded by 5 plane surfaces. It is a 3D figure with a rectangular cross section. The two opposite surfaces of prism are identical and parallel triangles, while the other 3 surfaces are rectangular and inclined to each other. So this is the diagram of prism. This is the prism, which is a 3D figure. So it is not possible to make in book, but they have shown you with this dotted lines. Now how light phenomena take place in prism? What happens? This incident ray, when it strikes the prism, we make an imaginary line, that is normal, and then it will bend towards the normal, which is called the refracted ray. And when this refracted ray strikes the side of the prism, again it will bend away from the normal, and we will get the emergent ray. So in this way, light phenomena take place in prism. Then we have dispersion of light. Now what is dispersion of light? Dispersion, the word dispersion means separation or things thrown in different places. This is the meaning of dispersion. Now what is the dispersion of white light, or you can say light? Now according to the scientist Newton, what he has done an experiment of white light which is coming from the sunlight. So Newton called white light from the sun to enter a dark room through a small aperture means a hole, in a window, and placed a glass prism in the path of the light rays. The light rays coming out. Now what Sir Newton has done, that he has made a small aperture, that is hole in the window, and in front of that hole the white light was coming, and in front of that white light he placed the glass prism. After that, what he has seen that this white light which is incident on the surface of the prism, it has been splitted into 7 colors called Weber. So this white light has been splitted into 7 colors of 7 different colors, which is called dispersion of white light. Now in this 7 color we have violet. V stands for violet, I stands for indigo, B stands for blue, G stands for green, Y stands for yellow, O stands for orange, and R stands for red. So white light has been separated into 7 different colors. This phenomena you can observe in at the rainy season, or when rain is seen. After that you can see a sunlight, then we see a rainbow in the sky, which is the example of dispersion of white light. So dispersion of light means when white light splits into 7 colors, it is called dispersion of light. Now what is the cause of dispersion? In class 7th you have already just read about this and understood about this, that white light of sun is composed of 7 prominent colors: violet, indigo, blue, green, yellow, orange, and red. The speed of light of all the color is same in air or vacuum, but it is different in transparent medium like prism, such as glass or water. In transparent medium such as glass or water, the speed of violet light is minimum and the speed of red light is maximum. Therefore, the refractive index, that is mu, which is constant, of transparent medium is also different for lights of different colors. So, which is represented as speed of light in air upon speed of light in the medium. So, the refractive index of a medium is maximum for violet light because the speed is less, and minimum for red light because the speed is more of red light. Therefore, when white light enters a prism, it splits into its constituent colors white, while refraction at the same surface of the prism. These colors get further separated from each other on refraction at the second surface of the prism. Okay, here you can see they have given the example of rainy season, that you can see rainbow which comprises of 7 colors, and this take place because of the splitting of white sun, light of sun into 7 colors. So this is the activity also. This is the proper picture which is given in the book. Light is entering from the hole. This is the white light, which is the light coming from sun, and it is splitting into 7 different colors. Then we have spherical mirrors. In a spherical mirror, we have two type of mirror, that is concave and convex. Because this mirror, a spherical mirror, is broken, and we got two mirrors, that is concave and convex. So the surface on which the silvering is done is called the silvered surface, and the reflection of light take place from the other surface, which is called the reflecting surface. So one surface is silvered. Silvered means, as you can see, the plane mirror, it has been painted from one side so that you can see your image on the other side. In the same way, one side is silvered, the another side is the glass side on which the light is thrown. So there are two types of spherical mirrors, concave mirror and convex mirror. Concave mirror is made by silvering on the outer surface of the hollow sphere, such as the reflection take place from the inside of the hollow. That is why, because it is making a cave, that is why it is called a concave mirror. Surface as shown in the figure, you can see in this figure 5.818. And next one is the convex mirror. A convex mirror is made by silvering on the inner surface, such as the reflection take place from outer convexed, or you can say the bulged area surface, as you can see in this figure 5.18, the B part, convex mirror. So in convex mirror, the reflecting side is the bulging one, and in concave mirror, the reflecting side is the hollow side is your reflecting side. Now we have some terms related to it. The first one is pole, center of curvature, radius of curvature, and principal axis. What is pole? The geometric center of the spherical surface of the mirror is called the pole of the mirror. The geometric center means the center of the mirror when it was fully complete. This point is called your pole. So the geometric center of the spherical mirror is called the pole. It is the midpoint of the aperture AB of the mirror, and it is represented by symbol P. So we have P for the pole. You can see this is the center part, and this is called the pole, this part, which is the center of the spherical mirror. And the next one is center of curvature. The center of curvature of the mirror is the center of the sphere on which the mirror is the part. So center of curvature is taken as the middle part of the whole of the spherical mirror, and pole is the middle part of the mirror. Suppose this is your mirror AB, so the middle part of this one is P, which is taken from the radius, and this radius is called as center of curvature. The next is radius of curvature. So radius of curvature is the radius of curvature of mirror is the radius of the sphere of which the mirror is the part. So this is called the radius of curvature. The distance between the center of curvature and the pole is called the radius of curvature. And the principal axis is the straight line joining the pole of the mirror to the center of curvature. So this is the principal axis which joins center of curvature and pole. This straight line is your principal axis, which passes from the middle of the concave or convex mirror. So in this video we will keep it till here. In the next video we will study about focus and the focal length, and then we will study about the rules of making ray diagram in the spherical mirror, in the convex and concave mirrors. We will also study about real and virtual images.